please take a picture of this page by your cell phones, or maybe you can take print screen with your PC. You will take 2 pages, or maybe just a second, I can fit it to window. Maybe it will be better for you. Yes, now it fits. This is the whole data that we will use. Is it okay? Anybody wants me to wait? Okay.
It's okay, no problem.
So let's turn back to EPANET again. The first thing we have to do is arrange some settings in EPANET. Before starting, we have to do some settings. First, let's start with project and defaults. We will make some settings here. In the ID labels, we can see some tools that are used by EPANET. For example, if I directly add a junction to somewhere, EPANET will name it by 1, and EPANET will name the second by 2, because the ID increment starts from 1. But it will name the junctions with numbers, and for example, the pipes with numbers and the tanks with numbers. So to distinguish them, it will be better to make them with different letters. So we will give them prefixes. For example, for junctions, it will start with J. So when I add a new junction here, it will be like J1, J2. Okay. With reservoirs R, for example, it's up to you. You can give any name that you will understand easily.
Hocam, sorry, but how did you open this screen?
Projects and defaults. Here, projects.
Okay.
Okay. For pipes, P. For pumps, they both start with the same letter, so I will name this one as PU. Valves, V. Patterns, for example, PT. And curves, C. Okay, when we finish this page, let's skip to properties, again in the same pop-up window. Node elevation, tank diameter, tank height, pipe length, auto length, pipe diameter, pipe roughness. You can directly add an item by using this toolbar. For example, this is for pipes. You can directly draw a pipe here. EPANET will not ask you what is the diameter of that pipe or what is the roughness of that pipe. It will assign these default parameters to. But in a project, most probably you will decide the pipe diameter by trial and error. So now these numbers are not so important. We can keep these default values here. But the only thing we have to change here is we should keep auto length off. Since I have made projects before, maybe it is about it. If your auto length is on, please close it. in this window. What does auto length means? This auto length means, for example, if you add a junction here and the second junction here and draw a pipe between these two junctions, AutoCAD will give a length to that pipe. It is same to this distance, which is seen in the screen. It will calculate the auto length that is for EPANET. So now we will not use it, so it will be closed. This is tank diameter, default diameter. This is unit is meter, diameter unit. Height unit is meter. Pipe length is meter, 1000 meter. This is 1 kilometer. Pipe diameter is millimeter. Be careful. Pipe diameter unit is not meter in EPANET. It is millimeter. So this is very small actually for our projects. It is about 1 centimeter. So let's change it. For example, 100 centimeter. If I didn't change it, when I run the project, it will give me an error and I will understand, oh, that means I forgot to change pipe diameter. I will change it easily. And pipe roughness. This is the C factor for Hazen-Williams formula because we will use Hazen-Williams for this project. I will show it to you right now. Now come to the hydraulics and let's check these settings here. Flow units, LPS. There are some flow units. We will use this one, liter per second. Head loss formula. There are some options, Hazen-Williams, Darcy-Weisbach, and Chesimeni. We will use Hazen-Williams. By the way, EPANET has a very good user manual. You can download it from its website. And all these things are described in that. Specific gravity, 1, that means we will use water. Relative viscosity, our viscosity will be same as the water, so it is 1. Maximum trials, we can keep these settings. These are this is the iteration numbers that EPANET uses for calculation. Accuracy, 0.1%. It is enough for our engineering applications. You will see what pattern and multiplier means. I will show. So you don't have to make another changes here. And if you want to, and I recommend you to check this box, not to enter all these values from the beginning for your projects. Okay, save as defaults for all new projects and okay. Any question up to now?
No, hocam.
Okay. And next thing, view dimensions. This map dimensions window is to arrange the borders of your screen. Now we don't need it, but maybe in your project you want to fit your drawing to your screen, maybe you can use it. Okay, so we don't use it. We can close. And view options. This is about visualization of our tools. node size. If you check this box proportional to value, the node size will be described depending on the pressure at that node. For example, if it has a pressure of 50 meters, 50-meter water column, okay, it's the head, it will be greater than the, for example, 30-meter water column head. I want to use this one. Let's check it. These are optional. These are all about your visualization preferences. Links. Link means a pipe or a pump. They are links. Again, I want to see their size proportional to their value. Labels. Okay, I will keep these one. Notation. And when I add a junction or pipe, I want to see their names near them. So I will check display node IDs, display link IDs. If you check this one, node values, EPANET will show you the pressure at that node, for example. If you check this one, EPANET will show you the velocity in that pipe link, for example. Now, I prefer to show these two. Symbols. I want to see all of my tools, of course, my tanks, my pumps, my valves, etc. And flow arrows. Now it is not so, it will not give me a flow arrow, but I want to see the flow directions in the pipes. So I will choose one of them. For example, fill. It will give me filled arrows on the pipes. Background. You can change background colors here. I will keep the white. And okay. Okay, now we are ready to draw our project. You have the screenshots or photographs in your cell phones. You can follow from there. Let's start with adding a new tank at reservoir. It will be somewhere here. And we will add our junctions. Junction 2 is here. Junction 3 here. But their label is changed because reservoir is a node as well. These are nodes, but junctions, node is the general name of these all. These are junctions. This is a node as well, but this is a reservoir. So number increment is because of that. I want to use the same numbers which are seen in the handout. So I will arrange them later. Now I will just continue to add a junction here, here. Okay. By the way, you will learn how to rename and how to see their properties. By just double clicking to this object or here, you can open its properties window. If you check the handout, you will see that the junction here is numbered with 7. I am doing this just because the values are written with these numbers in the handout. Okay. This will be junction 7. And junction 5 here. This will be 6. This is 5. This is 4. This is 3. And this is 2. Okay. Now I will add my tank with this button at the tank. It is named as T1. Okay, let's change it as T8 because the tank is numbered as 8 in the handout. Okay, and in the handout there are some labels. So let's add text. Add this T, and it writes here source. There will be a pump here. We still didn't that, but let's write it. It writes here tank. Okay, now we will add our pipes and pump. These are all nodes up to now. We have completed the nodes for this project. Now we will start links. So let's start with adding the pipes. You can click this button to add a new pipe. To keep the numbers, again, I will start from this one because number 1 pipe is here, from junction 2 to junction 3. Click junction 2 and click junction 3. Pipe 2 is here, from junction 3 to junction 7. Pipe 3 is here. Pipe 4 here. Pipe 5. Pipe 6. Pipe 7 is here. And pipe 8. As you can see, it's a curved pipe. So you can just draw a curved pipe by clicking. Look, I will start with from junction 5. To draw a curved pipe, just click somewhere you want. Click, click, like this. And you will end at the junction 6. This is the pipe 8. And finally, we will add the pump. This is very important, be careful. You will add a pump directly. I mean, you will not first add a pipe and after that add a pump on that. If you do that, EPANET will assume there is a parallel system here, which is first one is a pipe and the second one is a pump. They are working parallel. So you should directly add a pump like this. Add a pump from reservoir to junction 2. Okay. Any question up to now?
No hocam, clear.
Okay. And As I said before, now EPANET decided the properties of these tools as default values. Let's check it. For example, pipe 1. When you double click it, you can open its properties. Pipe ID, T1, start node junction 2, end node junction 3, length. It is 1000 because in our default settings, it was 1000. Diameter, we have changed it from 12 to 100. So it is 100. And roughness is 100. You can find these roughness values for various materials from the company's catalogs, or it is also exists in EPANET's user menu. In your project, you will decide which material you will use, and you will find this number from somewhere and give the reference of it. You will say, Hocam, I have used, for example, PVC pipe, and its roughness is this number because I am using this company's this diameter pipe. All the things in the project should be consistent with the real life. So that means, for example, you cannot use a pipe which is diameter is 100 meter. Okay. We will ask you, is there a pipe exist in real life or for a pump? Because EPANET allows you to use anything. You can use any power pump in EPANET, but it should be consistent with the real life.
Rajab, can I ask a question?
Yes.
What is the C factor in the handout? It's written for the pipes. There are C factors.
Yes.
As 100.
This is, you will write it here in Hazen-Williams formula. Okay. It is a constant described for materials.
Is it the loss coefficient?
No, we cannot directly say it. When you check the handout of EPANET, the user manual of EPANET, it is described detailedly. First, it will calculate an A coefficient by using that C. Okay, that A will be the loss coefficient. So this is a constant number depending on the material type. Okay, I will show it to you. So it will only take 1 minute. Since you have asked, I will show it to you. First, I should open the user's manual. So the roughness coefficients for NIPA, it says, if you are using Hazen-Williams formula, okay, you should use C factor for roughness. And their numbers are given for different materials. But if you are using Darcy-Weisbach, you should use these numbers. In your project, you can refer to this table. You can take the values from here. You can take it either here or a company catalog. Okay, it's up to you. And the thing I said, look, this is the resistance coefficient A. First, EPANET calculates this A by using these formulas. It's up to which formula you have used. Since you are using Hazen-Williams, by using that C, it will calculate A. And by using that A, it will calculate H loss. Okay. This is the theoretical background of these formulas. You can find it in the user's manual. You can download it in the website. Now I have opened my EPANET again. These length, diameter, roughness values are the default values that we have described before. Now we should arrange it by using our handout. Let's start with nodes. Node 1. This is a node. This is reservoir, but this is my node 1. Double click it to arrange its settings. In the handout, it writes its elevation is 213 and its demand 0. We will write its elevation to its total head. Since it is a reservoir, it writes total head instead of elevation here. So let's write here 230. Of course, it doesn't have a demand because it is a reservoir. It has the water itself. How can it has a demand? It is not a house. It is not a residual place. Okay, and close it. And the node 2. I'm continuing by nodes. After I complete nodes, I will start to pipes. Node 2. Elevation 213. Again, demand is 0. So I will keep 0 for the base demand. Close. Junction 3. Elevation 216. Base demand 9. Since we have chosen LPS, liter per second unit, this is 9 liter per second. In junction 3, there is a demand. For example, there is a house here and they need a flow 9 liter per second. Demand means this, okay? But in junction 2, there is no demand. So this is an imaginary junction. That means we will not take water from here. Maybe our reservoir is, for example, 5 kilometers far from our house. When I directly add a pump from reservoir to junction 3, I cannot describe this distance because for pumps, we cannot enter distance anywhere. For pumps, there is no length. So to include the length here, 5 kilometers, because there will be some major losses, some frictional losses in that pipe, and I want to include these losses to my system. So I will add an imaginary junction here. You can edit in your project as well. And give the length to this pipe. So this part has no length. This is just for pump. Okay, this is an imaginary length. And my real length is here. For example, if it is 5 kilometers, you will enter it here, 5,000. Okay, this is the main idea behind the junctions. Or for this one, maybe this is just an intersection. Okay, to intersect this pipe and this pipe, there should be a junction here. Even there is no house here, you should add a junction here because there is an intersection here. Okay, let's continue. Junction 3, we have entered the values. Junction 4, and I will look for node 4 from the table. Again, elevation 213. Demand 9. Okay, node. By the way, you can double click from here. Junction 5. Elevation 198. base demand 12, junction 6, elevation 230, and base demand 9, junction 7, elevation 230, base demand 0. That's the thing I said. Again, here there is no demand, but we have to add a junction here because it is an intersection point. Okay, close. In the table, there's a node with number 8. This one, this is a node tank. So double click it. Elevation 252. Here we will write 252, and it has no demand because it has the water as well. We can see some parameters for tank: initial level, minimum level, maximum level, diameter. They are all in meter. So as you can see, there's a diameter here. EPANET assumes this is a cylindrical tank. The circle is at the bottom, and it is a cylindrical tank. Now it assumes. But if you will use a tank which is shape is different than cylinder, you can use this volume curve. Okay. You don't have to use, but for example, if you have a tank shape conical, that means the water amount inside that tank will not linearly change with the height, right? If it is cylindrical or if it is cubic, it will change linearly. How much you have height, that much you will have water. But if it is conical or if it is T-shaped, imagine a T letter, up to some point, it will increase linearly, and up to that point, from that point, there is a sudden change in the water amount with height. So these are very detailed things. I just want you to tell the idea behind these things, but you don't have to use. Okay. Now, any property? Yes, in the handout it writes the tank has a 18-meter diameter. At the end of the page, you can see the descriptions. The tank has a 18-meter diameter. So let's write it here. And a 1-meter water level, that means its initial level is 1 meter, maximum level of 6 meters. Yes. So our cylindrical tank has a 18-meter diameter, like this circle, and it is 86 meters. You can imagine 2 stories apartment, and initially 1 meter water inside it. Okay, we can close this one. And let's start the pipes. Pipe 1. Pipe 1 length is 914. Diameter 350. Be careful, this is millimeter. Okay, you don't have to write meter here. It is given as 350 millimeter. I can directly write it here. EPANET understands that the number that I wrote length is meter, but the number that I wrote to diameter is millimeter. And C factor, we will write C factor, the roughness It is 100, so we don't have to change. Pipe 2, length 1524, diameter 300, roughness 100. Pipe 3, again same. This is 200. Pipe 4, pipe 5, pipe 6, length 2133, diameter 250. Pipe 7, diameter, and finally pipe 8, diameter 150. Okay. We have described the properties for nodes. We have described the properties for links, except pump. Pump is a link as well, but we have to arrange its properties. For pump, in the handout it's given, the pump can deliver 45 meters of head at a flow of 37 liters per second. Have you covered the pumps topic in the lectures?
I think yes, hocam.
So anybody heard pump curve?
Yes, hocam.
Okay. So we have to describe the pump curve for the pump. In the data browser's data section, click this drop-down menu and choose curves. And click this add button. It will automatically add a new curve called C1 because we have given the C name for the curve. Curve ID C1. Description. Let's write pump curve. It's not important. You can write or you can't. So in the handout, it writes the pump can deliver 45 meters of head, 45 meters of head at a flow of 37. So this means this pump can supply 37 liters per second flow rate to 45 meters. We are not given the power of the pump in terms of kilowatt. We are describing a pump curve. And click OK. Let's check it again by double clicking. Yes, it has created a pump curve for me. Okay. If you have more than one value, you can enter the other values here. Okay. Again, you can take the pump curve values from the pump companies. If you have more than one value, it will be more precise. Your curve will be more precise. Okay, let's close it. We have described the curve, but our pump doesn't know it. So I will say my pump, you should use curve 1. Double click pump properties and you will write here hey, pump 1, you will use curve 1, C1. Okay. Let's do a final check whether we have forgot something or not. I think we didn't. Okay, let's check. Let's try to run it. Yes, it says run was successful. It gives me the flow arrows directly. We can see the flow direction. For example, from pipe 5 from left to right, for pipe 3 from top to bottom, etc. These are the flow directions. But I want to see the pressures, velocities as well. So in the map of browsers map section for nodes, for example, I want to see the pressures. Yes, this is the legend. Junction 2, it is between 25 and 50 meters, for example. And for links, I want to see the velocities. The green ones are between 0.1 and 1. But now I cannot see my arrows easily, so I will increase the size of the arrows. Wheel options, flow arrows, arrow size. It is now 5, let's make it 10. Okay. Yes, now it's better. Any question up to now? Do you want to speak?
I want to ask a question. On junction 8, how is it that the flows from both pipe 7 and pipe 8, they are both going to junction 8?
Let me check. Junction
8
Junction
down.
5 hocam.
is junction 8.
Ah, 5, sorry, 5. I couldn't see it correctly.
Junction 5, yes. Yes, it can take, for example, let's say if
The
there's
flow
a
of water.
You say, how can it take water from both sides, right?
Yes.
Okay. This is a safe house in terms of water cut. Okay, if you are living here, for example, if there is a break in this pipe, you can take water from this pipe. So the loop systems advantage of this one, not only this one, but also this pipe can take this junction, I'm sorry, this house can take water from these 3 ones. Even you break this one and this one, it can take water from this one. Now, the arrows shows me this case. This is a steady solution. But next we will give the daily water usage pattern to EPANET, and it will calculate it for us.